I'm Nick. I started Nick's Electronics Repair over a decade ago, and in the last year, we have fixed hundreds of these oven controller boards. Today, I'm going to be showing you how to fix some of the common faults, such as dim display, the oven's not reaching temperature, F3 error code, and I'll also have a little bonus at the end of this video. These are the components we'll be installing today. We have a brand new display, which comes with a double-sided sticky pad, these capacitors, and these two relays. First, let's start with the display replacement. As you can tell, I am seeing 727 locked, but it is very dim. It's hard to see what's being displayed on screen. Let's remove the plastic case so we can access that display. If you want to try and fix the controller board yourself, we will have the kits available on our website, and the listing will be linked in the description below. Our display has 3 pins here, 3 pins here, we have 3 more here, here, and then in the center we have all of our data lines. So I'm going to use some Kenmore for the desoldering process. And so now we should at least be able to lift it up. So these are the 6 pins we just desoldered. We'll do the same process at the bottom. And to check, I'm just going to push the pins around to make sure I can move them, and I can. We'll do the same over here. Yep, and we'll keep running through the same process for the bottom pins. And the display just fell out. So this is the display we are removing, 7-LT-91G. You'll notice there are 2 sets of 3 pins at the top and bottom, whereas our replacement has only 2 pins and no pins on the other side. And that's totally okay because some of those pins are redundancies and others are for support. So as a replacement for our support, we are going to be using that double-sided sticky pad. So I'm going to remove the waxed paper layer here. I'm noticing the processor is a little dirty. So we're going to give it a quick little clean here so we have a good clean surface to adhere to. And I'm using isopropyl alcohol and a Q-tip. All right, we can put our pad down. We'll remove the other layer of wax paper. And now we will carefully line up our replacement display, feeding all the pins into the holes. You're going to probably have to do a little bit of wiggling. And there we go. The display is now locked in. It is not falling out. So now we can go ahead and solder it in. If you do not have the tools to perform this repair, we also have a mail-in service available, which comes with a 1-year warranty. I'm going to use my magnifier to do a quick check on the pins. I want to make sure that I have no bridges, and I don't. And this is what our display looks like. So it's definitely a little brighter, but you'll notice on the plastic cover here, there's a little bit of a smoke residue. So we'll definitely want to clean that up as well so we can have a very clear display. The customer that sent in this controller board for us to fix had 2 complaints. Number 1 was the display was very dim, and number 2, the oven was not reaching temperature. That's going to be where these 2 relays come into play. As you can tell, they're right over here next to our transformer, and they will feed our baking and broil element pins. If I flip it over, I'm going to notice a little burning right there. So we're actually going to switch over to the microscope for this one. And we're going to start by looking at a relay joint that looks okay versus the burnt one we just noticed. And as you can tell, there's a lot of burn damage here. So it's actually very rare for the relay itself to become defective and fail. Most often it's just that joint that needs to be cleaned up and resoldered, and most of the time that will resolve the issue. When I say most of the time, I'm talking about 99.5% of the time. It's very rare to see the actual relay fail. However, because we do sometimes see it, we are going to include in the kits 2 relays for you to be able to replace those if you need to. Each relay has 4 pins. We have one right here that I'm soldering to. Just trying to get some good flow first by adding solder. And these 2 down here. Now that I have good flow, we can go ahead and remove the solder we added along with the original solder with the desolder braid. So these are much larger pads, obviously, as you can tell. So they will take a little bit extra heat to melt. Oh, and the relay just fell through. So that's the original relay. And something I'd like to do is clean up the burnt joint a little bit more, just so we have a good surface to solder to for the replacement. We're gonna clean up a little bit of that flux. So I didn't add flux, but the solder we use does have a flux core, and the solder braid that we use also has flux on it. So that's where all this spent flux is coming from. So for the installation, I am holding the relay from the bottom with my hand, and we're gonna solder in, lock in some of the pins from the top, and it looks like locking just one in is enough, so I can let it go. We're gonna go ahead and add a little bit of fresh solder to our damaged pin. If you want to use the same solder and desolder braid that we use, I'll also have links for those, which you can get from Amazon. So I'm actually going to hang out on this joint for a little longer because this is a much larger pad, and I really want to make sure I have good heat transfer. Now these two down here are more for signal. It's just 9 to 12 volts coming through, so we don't need to go the extra mile for those joints. Do a quick cleanup, remove some of the extra flux we added here, and then same process for the second relay. So this time around, I'm trying to do it without adding fresh new solder. Typically I'll do that, especially if I have a burnt joint, because those are going to be a lot harder to flow. But I think I might be able to get away without adding fresh solder here. Could be wrong, we'll see in a second. As you can tell, my flow is not as good. There we go. So that did take a little longer, so there is a benefit to adding a little bit of solder first, getting good flow, and then going for the desoldering. Same process, we'll go ahead and do a cleanup, remove the spent flux. Using the same strategy, I'm holding the relay from the bottom side with my hand. So this time around, let's add just a little bit of flux before we start our soldering. There we go. We're going to do a multimeter check for continuity to make sure that the relays are working properly. I did clean up the front cover, just rinsed it off with some hot water, and then used a soft bristle toothbrush and some soap, just gave it a light scrubbing, a little rinse, and here we are. We're going to engage the broil first. So when we have a beep, we have continuity. It just clicked on, and we have continuity. All right, let's cancel. Let's do the bake. This is the one that was actually the issue. So typically we don't have continuity at first. It goes to broil first, which it does, but then it'll click off and then it'll go to the bake element in a second. And there we are. So that does confirm both of our replacement relays are functioning as they should, and the controller board is now feeding proper power to the baking element. Next, let's tackle the F3 error code. The F3 error code typically is triggered because it is not able to detect some of the sensors. Usually, just like the relay, that is caused by a cracked solder joint. So for this one, we're going to switch back over to the microscope once more, and we're going to want to focus on these pins over here. Now, this is not an issue that the customer was experiencing with this controller board, but if they were, these pins would be the cause of the fault. So what we want to do here, and we'll do this with every repair typically, is reflow these pins to prevent an F3 code from happening in the future. And finally, we're going to be replacing the electrolytic capacitors on the board. Now for this circuit board, it is not necessary at this time. However, in the near future, it is possible that they are going to start leaking some of that electrolytic fluid onto the board. When that happens, we get lots of corrosion, and sometimes it can even start a small little fire. So this is more of a safety issue as well as functionality. For this one, we're going to want to add just a little solder. We definitely want to make sure we get good flow for these. And part of the reason is because these are actually a little easier to accidentally damage the trace. All right, I'm gonna give it a gentle wiggle from the bottom, and I wanna make sure both my legs are loose, and they are, which then means it's safe for me to remove from the top. I'm just gonna wiggle it out as gently as possible. This first one is 470 microfarad, 16 volts. And of course, that is exactly what our replacement is rated for. As you can see, there is a black line over here indicating the negative side. And we also have a negative emblem on the capacitor. And we're gonna push it all the way in. Our next one is this large one. Same thing, just a little bit of extra solder, get some good flow. This one, the pins are not bent, so it should, in theory, be a little bit easier for us to desolder it. Okay, is it loose? And it is. So this one is a 3300 microfarad, 16 volts. And that, of course, is the same value as our brand new replacement. Now this one, the line is kind of hidden under the transformer, but it is present. And of course, it is also present on the capacitor itself. This one, I'm gonna bend the pins out just a little bit to help lock it in. And then finally, we have these two guys. So this one's also 470 microfarad, 16 volts. And that one is right there. Okay, and we have wiggling. Same process, make sure that we are inserting it in the correct orientation. And we have our final one at location ID C9. And we have wiggling. Definitely want to be sure of that. If you're not and you pull it through, you're going to rip a pad. And now this one is actually a 100 microfarad, 50 volts, so it is a little different. Definitely make sure to double check the ratings and the orientation before you install the capacitors. So final check on orientation, we have our negative over here and the black line, negative, black line. We have the black line and our negative in there, hard to see, but it is there. And then same, we have the black line and our negative. And finally, our bonus. For these oven controller boards, the majority of the time, issues are due to cracked solder joints. So one of the things that we do with every single repair is a full reflow of all the high voltage areas. That includes the transformer, every single relay, even the ones we didn't replace, and all of the spade connectors at the top. So we're gonna start with this relay over here, the spade connectors, and then this relay over here. So these have 5 pins. And again, these don't have any immediate faults, but the reason we like to reflow them every single time is because we do on occasion see them come in with problems, with crack joints. And if we're gonna spend the time to open up this controller board and repair it, replace the display, replace some of the relays, might as well do the full job correctly so that we don't have any repeat issues. We're just going down all the spade connectors right now. And then finally our other rectangular relay on the other side, which this one I believe is for the convection baking. And finally we have our transformer over here. And again, this one does look okay. We don't have any cracked solder joints, but it does happen on occasion. So we will also reflow it, reinforce it. So that does complete the kit installation and full refurbishment for this oven controller board. If you found the video helpful or useful, leave us a like, subscribe for more content, and thank you for watching.